In this video, we are going to be working with decimals and their place values. Let's start with a quick review of the place value chart and what it looks like with decimals. At the end of whole numbers, there is a decimal. We don't write the decimal when the number is a whole number, but it is important to understand that we can put the decimal at the end of any whole number and it won't change the number's value. Let's use money for an example. We can write $2 and know that it is 2 whole dollars with no change. If we add the decimal to the end and make it $2 written like this, the value didn't change by adding the decimal and the 2 zeros. But we need to be able to add the decimal to the end of a whole number when we want to add a fractional part to the number. Let's look at the money example again. We can add a dime to our $2 and make it $2.10. Now the decimal is separating the whole number from the fractional part. This is also why we write 10 cents like this. Because here we have no whole dollars, but there is a fraction of a dollar, so we put it behind the decimal. Look back at the place value chart. Behind the decimal are the fractional parts. We have tenths, hundredths, thousandths, and so on. If you look at the place value chart now, you can see the pattern working out from the ones place. Tens, tenths, hundred, hundredths, and so on. Let's review what it looks like when converting from a fraction to a decimal using some base 10 blocks. Here we have one whole block plus a block divided into 10 equal parts. The first whole block and 2 parts of the second block are colored in, so we have 1 whole plus 2 tenths. As a mixed number, we would write that as 1 and 2 tenths. Let's convert that to a decimal number. The 1 represents 1 whole, so that goes into the ones place. The 2 represents 2 tenths, so that goes into the tenths place. So we have 1 and 2 tenths equaling 1 and 2 tenths. Let's do one more. This time we have one whole block and another block that is divided into 100 equal pieces. The whole block is shaded in again, so again we have one whole. This time we have 4 hundredths shaded in on the second block. We write that as 4 100ths. Now let's move that over under the place value chart. We put the 1 in the ones place again to show that there is one whole block colored in. Then we put the 4 in a hundredths place to show that 4 out of 100 pieces in the second block are colored in. Notice that we have a blank spot where the tenths go. Look back at the place value block for the 4 hundredths. We don't have any complete columns colored in, so we will put a 0 in the tenths place. So 1 and 4 hundredths is written equally like this. Our last problem is a single block divided into 100 parts. So as a fraction, we would write 27 hundredths because 27 of the 100 pieces are shaded in. This time, we put a 0 in the ones place to show that there are no whole blocks. Now, to write the 27, the last digit of the number should always be in the place that is said. Since it is hundredths, we put the 27 so that the 7 is in the hundredths place. So let's look at our takeaways from today's lesson. 1. Remember that you can add zeros to the end of a number after a decimal and it won't change the value of the number. So 34 is equal to 34. Number 2, the part to the right of the decimal is the fractional part. We can write it as a fraction or a decimal. So 7 tenths is the same as 7 tenths. Number 3, when writing in decimal form, the very last digit behind the decimal goes in the place value spot of the said word. So 1 and 9 100ths, the 9 goes in the hundredths spot and we have to fill in the tenths spot with a 0. Tomorrow we will be working with more decimals. Please make sure to go and do your study island. Yesterday we looked at how to write decimals and how to change fractions into decimals. In today's lesson we are going to learn how to correctly read decimals and how to compare them. To read a number that is a decimal, we say the word "and" where the decimal is placed. In front of the decimal we read the number as a whole number like normal, then say "and", then read the number behind the decimal the same as a whole number, but instead we add the place value name with the th sound at the end of the final word to show that it is a decimal. Look at this number. We read the whole number in front first, 6. Then we say "and" for the decimal. Then we read the last number, 5, and add the place value of the 5. So we have 6 and 5/10. Let's look at a larger number. We would read this as 7,644 and 39 hundredths, showing that the last digit is in the hundredths place. Let's move on and do some comparing. Let's look at a decimal with some place value blocks. This block represents one whole and is divided equally into 10 parts. One row out of the 10 is colored in, so we have 1/10 colored in. As a decimal, we want to write 0 and 1/10, so that the 1 is in the tenths place. Now we have the same size block divided equally into 10 rows and 10 columns so that we have 100 pieces. In this example, I have 10 little blocks colored in out of 100, so I now have 10 100ths colored in. So we write this as 10 100ths. Because we only have 100 parts, we cannot write past the hundredths place, so the 1 regroups into the tenths place. So now look at the two blocks. We have this first block that has 1/10 colored in, and the second block that has 10 hundredths colored in. Do you notice anything? Yes, they are equal. 1/10 is equal to 10 hundredths. The 0 that is added onto the second decimal just means that it came from a 100 block. But since 10 hundredths is the same as 1/10, the last 0 isn't needed. It is just like reducing a fraction. Let's do some comparing using greater than, less than, and equal to. Let's do 54 and 6/10 compared to 5 and 4/10. First, look at the whole numbers only. We have a 54 in front here and a 5 in front here. Which is larger? Since the 54 is clearly larger than the 5, we don't even have to look at the decimal part of these numbers. We can see that 54 and 6/10 is greater than 5 and 4/10. But what if the whole numbers aren't there? Let's look at 6/10 and 4/10. Since we don't have whole numbers, we see those zeros in front of the decimals. So we look at the digits behind the decimal, one place at a time, starting with the tenths place. In this one, we have a 6 and a 4. Since the 6 is greater, we don't have to do anything else. 6/10 is greater than 4/10. Pretty simple. Let's try some more difficult ones. Here we have 7 and 56 hundredths and 75 and 6/10. At first glance, they look like the same number, but remember to always look at the whole numbers first. With this comparison, the 7 is much smaller than the 75. So the answer is less than. We don't have to worry about the decimal part because the whole numbers already tell us the answer. Let's try this one. 7 and 56 hundredths and 7 and 5/10. This one is a little trickier. First, check the whole numbers. Since they are the same, we have to look at the digits behind the decimal. We have a 56 and we have a 5. Clearly the 56 is larger than 5. We can check ourselves by adding a 0 behind the 5 in the second number. Since it is behind a decimal, remember we can add a 0 to the back and it won't change the value. So we can change it to 7 56 hundredths and 7 50 hundredths. It is easier to add the 0 to the end so that each number has the same number of digits behind the decimal. It doesn't seem to matter in this one, but look at this next question. 4/10 and 34 hundredths. Again, we start with the whole number. Since it is a 0 and a 0, we have to look behind the decimal. We start at the tenths place. We have a 4 and a 3. Since the 4 is greater than the 3, 4/10 is greater than 34 hundredths. We don't even have to look at the hundredths place. This can look confusing, but if you look at all the digits behind the decimal, 34 looks bigger than 4. But remember, when we add a 0 to the end, it doesn't change the value. So let's check ourselves. Let's add a 0 to 4/10 so that it has an equal number of digits. Now you can clearly see that 40 is greater than 34. Let's look at this one a little more closely by using the base 10 blocks. Here are 2 blocks colored in to match the decimals, 4/10 of the first one and 34 hundredths of the second one. If I add a 0 and change it to 40 hundredths, you can easily see how 4/10 is greater and that the added 0 didn't change the value of the 4/10. So let's look at our takeaways from today's lesson. 1. Remember to say the word "and" to represent the decimal when naming a number that has a fractional part. 2. When comparing decimals, always check the whole number in front of the decimal first. Then if you have to move to the fractional part, add zeros to the end of the decimal so that both numbers have the same number of digits behind the decimal. Then you can compare. Tomorrow we will be working with more on decimals, so please make sure you go in today and do your study island assignments. Expanded form of decimals. Now that we have learned how to read and compare decimals, we need to look at the different ways to write decimals in expanded form. Remember, expanded form is when we take a number and pull it apart into its values based on their place in the number. In the number 763, we have 7 hundredths, 6 tenths, and 3 ones. So we can write the expanded form by writing the value of each digit. The digit 7 has the value of 700, the 6 has a value of 60, and the 3 has the value of 3 ones, which is just 3. We put the plus sign between each one to show the expanded form of the number 763. This works the same for a decimal. Let's add 49 hundredths to that number so that we now have 763 and 49 hundredths. To write it in expanded form, first write the values of each digit. Again, the 7 is valued at 700. The 6 is 60, and the 3 is 3. For the fractional part, write their values in fractional form. So the value of the 4 is 4/10, and the 9 is 9/100. So in expanded form, it is 700 plus 60 plus 3 plus 4/10 plus 9 hundredths. Let's look at different ways we can write the same number in expanded form. The first one is what we just did. We can take it to the next step by separating the digits from their place value. So 700 is written as 7 times 100 because 7 is the digit and its value is 100. So we have 7 in the hundreds, which is 7 times 100, 6 in the tens, which is 6 times 10, and 3 in the ones, so that is 3 times 1. For the decimal part, we have 4 in the tenths place, so we write 4 times 1/10, and for the 9 hundredths, we write 9 times 1/100th. So for the expanded form, we add the plus signs between each one. 7 times 100 plus 6 times 10 plus 3 times 1 plus 4 times 1/10 plus 9 times 1/100th. The final way we will be doing today is actually writing the decimal form of fractional parts. It will look the same for the whole number part, but for the fractional part, you will write the fraction as a decimal. 700 plus 60 plus 3 plus 4/10 plus 9/100. When we expanded the number one step further, it looks like this. 7 times 100 plus 6 times 10 plus 3 times 1 plus 4 times 1/10 plus 9 times 1/100. We can add parentheses around the individual parts so that it is easily read, but it isn't necessary due to the order of operations. This concludes this week's lessons. Make sure you have done all 3 assignments for the week.